This is the information. This is example 2. We did example 1 yesterday. This is the information that they gave us. The only thing they told us is that cosine is -5/13. And this represents the interval. Okay, so this is going to tell us what quadrant we're in. This is why they give us this information. So what quadrant do you think we are in if we start at pi and end at 3π/2? So what would be our quadrant? What quadrant starts at pi and ends at 3π/2?
Quadrant 3?
Yep, quadrant 3. So we know we're in quadrant 3. And in quadrant 3, we know that sine and cosine are negative. So if we kind of look ahead, we can see that with cosine double angle, we can do this question first. We can find our cosine double angle using only cosine because we have 3 choices, and we do have a choice that only uses cosine. But in order to find our sine double angle and our tangent double angle, we need to know the other 2. We have to find sine, and we will need to find tangent. So my opinion is that we should just start by finding those other 2 first. Before we try to find the double angle, let's start by finding our sine ratio and our tangent ratio. So we know that cosine is x/r, and we know that r² equals x² plus y². This is also a Pythagorean triple, so you may be able to figure this out without doing this process, but I'm going to work through the process just in case someone doesn't recognize what the y value would be. So we know that r is 13, so we're going to take 13 squared, and that equals x² plus y². So 13 times 13 is 169. That equals 25 plus y². So we're going to subtract our 25 from both sides. And then I'll give you a minute to try to finish this out and find y. So was anybody able to figure out what y would equal? Anybody want to volunteer what they got?
12.
12, yeah. So we know that this is going to be 144. And when we take the square root, that y is 12. So now that we have this information, I'm going to go under my identity here. So they gave us cosine. I'm going to write this here. We know cosine of theta is -5/13. Now we can figure out sine, because sine is y/r, so that would be 12/13. We'll write that, y/r. And we also know tangent. Tangent is y/x. So that would be 12/5. So now let's look at what we know about what quadrant we're in. We're in quadrant 3. In quadrant 3, because remember, let me zoom out. In quadrant 3, the only 2 that are negative will be sine and cosine. So I have to make this 12/13. That needs to be negative. And tangent will stay positive. Okay, so now that we've done that legwork, we're ready to go. The rest is simple.
Wait, I have a question.
Yes.
Why is the 5 for tangent not negative?
So it doesn't matter if the fraction has to be negative. It doesn't matter where you put the negative. So
Oh,
that
okay.
5 doesn't necessarily stay negative. I mean, I guess in theory you could say that the 5 and the 12 are negative here, which is why
Mm-hmm.
it's positive.
Oh, okay. Thank
Okay.
you.
But just know the ratio is going to be positive. Okay, so now any other questions before I erase and start finding our 3? Okay, so now let's look at it. So we have 3 choices in order to find our cosine double angle. We can use, because we know sine and cosine, we can use the first one, we can use the second one, or we can use the third one. And they're all the same. You get the same answer regardless of which one we choose. So I think to be different, because we haven't done this yet, I haven't used it yet, I'm going to use this one for my cosine double angle. So if we use that one, it says cosine double angle. And remember, it could be theta. So the question here uses theta. This formula sheet uses a capital A. I think the pink sheet, what does the pink sheet use? Pink sheet uses theta. It could use X. This is just a variable. All right, so I'm using this first one. No reason why, really honestly, because I haven't used it yet. So we got to take our cosine of theta squared and subtract from it our sine. Okay, so we know. So let me set this up. So we figured out our cosine. Well, actually, they gave us our cosine. And our cosine is negative 5 over 13. And then we know our sine is negative 12 over 13. So order of operations, we should do our exponent first. And when you square a fraction, you're squaring top and bottom. So that would be 25 over 169. Because this fraction becomes positive because I'm squaring a negative. Minus, and then I'm squaring my second fraction. Hold on, let me see something real quick. 1034. Okay, just making sure I'm paying attention to time. Okay, when I square my second fraction, it becomes a positive 144 over 169. We have our common denominator, so we just need to subtract our numerator. And again, you don't get to use a calculator, so you will have to do the old school way off to the side. And I'll give you a minute to figure out what you get. And because we're taking 25 minus 144, I know my ratio is going to be negative. And if you did your math right, you should get negative 119. So that is my cosine double angle. I actually did this 5th period and I used a different identity. I think I used this one, but we got the same answer. So cosine double angle is really friendly because they gave us 3 options to get there. They said, here's 3 different road maps. You pick the road map you want to use to get to the destination. So that would be my cosine double angle. Any questions about how we did cosine double angle? All right, I'll give you a minute or so to either take a screenshot of this or write it down, and then we're going to do our sine double angle. Okay. So now to do our sine double angle, go ahead and take this off. So our sine double angle, we only have one choice. And this is the choice we have for sine double angle. So it says to find sine of 2 theta, you're going to take 2 times the sine of theta times the cosine of theta. So that would be 2 times sine. Sine is negative 12 over 13 times our cosine, which is negative 5 over 13. And remember, every fraction can be written, every number can be written as a fraction if you put a 1 under it. So we're just multiplying straight across. So you're going to just, again, no calculator. You're multiplying all 3 of these numbers to get the numerator, and then all 3 of these numbers to get your denominator. So you're taking 2 times negative 12 times negative 5 over 1 times 13 times 13. So when you do that, you should get, let me see, 12 times 5 is 60. So you should get a positive 120 over 169, and that would be your sine double angle. So that one's pretty easy to get to. So we did our cosine double angle and we did our sine double angle. So I'll give you a moment to copy this down if you haven't, or take a screenshot, and then we will finish up with our tangent double angle. Okay. And now let's do tangent. So tangent double angle, we only have one choice. It's only one option. This is our tangent. And tangent only uses tangent. That's all it uses. It doesn't use sine or cosine. So if you're trying to find a tangent double angle, you have to know the tangent. So tangent of 2 theta is going to equal, and it says you take, so in the tangent, let me make sure you understand this identity. You're putting it here and here. So to find our tangent, you're going to take 2 times tangent divided by 1 minus tangent squared. So in the parentheses, let's drop in our tangent. We're going to put our 12 over 5 here and here. And then from here, we're just following the order of operations. So in my numerator, I have 2 over 1 times 12 over 5, which would be 24 over 5. 1 minus, and then we need to square 12 over 5, which would give us 144 over 25. So now we're ready to subtract. So my numerator is 24 over 5. I'm going to leave that there. My denominator, I have to take 1 minus 144 over 25. So I'm going to rewrite 1 as 25 over 25. Because 25 over 25 is the same as 1. But now I can subtract the 144 over 25. So we got to do, we already did this. So we did 144 minus 25 when we did the, wait, did we do 144 minus? I feel like we did that when we did our cosine double angle. So if you do 144 minus 25, you know, off to the side, we know it's going to be negative. And you should get the negative 119 over 25. So we're dividing these fractions. And when you divide fractions, we do a keep, change, flip. So that's going to give us 24 over 5 times, and then we flip it, 25 over negative 119. So that looks like some big numbers. You're probably like, man, I got to take 24 times 25 without a calculator. And then I have to take 5 times 119 without a calculator. No, you don't actually, because we can cross simplify. And this is an example where it would make sense to reduce these two numbers, because what can I divide into 5 and 25? What number goes into 5 and 25?
5.
5. So what I would do is I would take the 5 divided by 5, which would change this to a 1. And then I would take the 24 divided by 5, which would make that a 5. And that makes our multiplication a little easier, because now we're just taking 24 times 5 and multiplying and putting that over 1 times negative 119. So the only thing you're essentially having to multiply is 24 times 5. So off to the side in the kitchen. Oops, sorry, my screen jumped like that. Take the 24 times 5. See what you get. So we know that 4 times 5 is 20. Add the 2. So your final answer for tangent double angle should be, and I want to make sure you understand that when you have a negative, I put the negative in my denominator, but I'm actually going to move that to the front. The negative just has to be somewhere in the fraction. It doesn't matter where that negative goes. It could go upstairs, it could go downstairs, but I usually just put it in the front. And that would be my tangent double angle. So at this point, you can do numbers 3, 4, and 5 in homework 12. Tomorrow, we're going to talk about solving equations that involve a double angle. And then we will also start half angle identities. So a couple of reminders. Homework 11 is due tomorrow. Skills check is on Thursday. Homework 12 is due Friday. And you still have, it's a 6-point assignment on Canvas. If you have not done that, make sure you get that in before it closes.